Chemical engineering was first established as a profession more than a century ago and has grown to span a diverse range of industries. As the Institution of Chemical Engineering celebrates its centenary, we look at the evolution of the sector and its place in society today.
Chemical engineers help to create the world we live in, from life-saving medical equipment to the screen you're watching this film on, and even the adhesive on the humble post-it note. The Institution of Chemical Engineers, IChemE, was established in 1922. In that time, the world of chemical engineering has changed, from just transforming raw materials into useful products to designing, constructing and managing complex processes that help to solve the global grand challenges. Chemical engineering has helped to save and improve millions of lives. In 1928, penicillin was discovered, but by 1940 there was still only enough for a few people. It took chemical engineers to scale up, and by 1945 over 640 billion doses per year were being produced. Today, this ability to take something in the lab and produce it for the masses quickly and cheaply helped in the momentous task of delivering COVID-19 vaccines globally. But it's not just about going big. In the future, chemical engineers will help to engineer medicines to be personal to each patient. Chemical engineers look at the full picture. Energy, food, water and climate change are all connected. In the early 20th century, chemical engineers were at the heart of the extraction, refining and distribution of fossil fuels, fueling prosperity and revolutionising transport for everyone. But now their focus is in the transition towards net zero by 2050. Renewable energy and hydrogen are two of the answers. The problem is the batteries and fuel cells needed to store and use the clean energy require finite metals and minerals. Chemical engineers are at the forefront of developing ways to store energy sustainably. At the turn of the 20th century, the bulk manufacture of ammonia to produce ammonium nitrate and urea revolutionised the amount of fertiliser that could be made. Half the world's population is fed due to this breakthrough. But food production is intensive and emits CO2. Chemical engineers are playing an increasing role in making agriculture in many industries more carbon neutral. And clean water is essential for life. The chemical treatment of wastewater has helped to eliminate or reduce many diseases. But water is set to become a scarce resource in many parts of the world. Take biofuels, a low-carbon alternative to fossil fuels, but it can take 10,000 times more water to make it. Chemical engineers need to reduce demand of water for agriculture and manufacturing. Tackling climate change is embedded in the thinking and design of new products and processes, from small modular nuclear reactors made on a production line to plastic that recycles multiple times and then eventually biodegrades. Chemical engineers are at the forefront of a circular economy, helping to solve the major global issues of today and tomorrow.
Chemical engineering was first established as a profession more than a century ago and has grown to span a diverse range of industries. As the Institution of Chemical Engineering celebrates its centenary, we look at the evolution of the sector and its place in society today.
Chemical engineers help to create the world we live in, from life-saving medical equipment to the screen you're watching this film on, and even the adhesive on the humble post-it note. The Institution of Chemical Engineers, IChemE, was established in 1922. In that time, the world of chemical engineering has changed, from just transforming raw materials into useful products to designing, constructing and managing complex processes that help to solve the global grand challenges. Chemical engineering has helped to save and improve millions of lives. In 1928, penicillin was discovered, but by 1940 there was still only enough for a few people. It took chemical engineers to scale up, and by 1945 over 640 billion doses per year were being produced. Today, this ability to take something in the lab and produce it for the masses quickly and cheaply helped in the momentous task of delivering COVID-19 vaccines globally. But it's not just about going big. In the future, chemical engineers will help to engineer medicines to be personal to each patient. Chemical engineers look at the full picture. Energy, food, water and climate change are all connected. In the early 20th century, chemical engineers were at the heart of the extraction, refining and distribution of fossil fuels, fueling prosperity and revolutionising transport for everyone. But now their focus is in the transition towards net zero by 2050. Renewable energy and hydrogen are two of the answers. The problem is the batteries and fuel cells needed to store and use the clean energy require finite metals and minerals. Chemical engineers are at the forefront of developing ways to store energy sustainably. At the turn of the 20th century, the bulk manufacture of ammonia to produce ammonium nitrate and urea revolutionised the amount of fertiliser that could be made. Half the world's population is fed due to this breakthrough. But food production is intensive and emits CO2. Chemical engineers are playing an increasing role in making agriculture and many industries more carbon neutral. And clean water is essential for life. The chemical treatment of wastewater has helped to eliminate or reduce many diseases. But water is set to become a scarce resource in many parts of the world. Take biofuels, a low-carbon alternative to fossil fuels, but it can take 10,000 times more water to make it. Chemical engineers need to reduce demand of water for agriculture and manufacturing. Tackling climate change is embedded in the thinking and design of new products and processes, from small modular nuclear reactors made on a production line to plastic that recycles multiple times and then eventually biodegrades. Chemical engineers are at the forefront of a circular economy, helping to solve the major global issues of today and tomorrow.
Chemical engineering was first established as a profession more than a century ago and has grown to span a diverse range of industries. As the Institution of Chemical Engineering celebrates its centenary, we look at the evolution of the sector and its place in society today.
Chemical engineers help to create the world we live in, from life-saving medical equipment to the screen you're watching this film on, and even the adhesive on the humble post-it note. The Institution of Chemical Engineers, IChemE, was established in 1922. In that time, the world of chemical engineering has changed, from just transforming raw materials into useful products to designing, constructing and managing complex processes that help to solve the global grand challenges. Chemical engineering has helped to save and improve millions of lives. In 1928, penicillin was discovered, but by 1940 there was still only enough for a few people. It took chemical engineers to scale up, and by 1945 over 640 billion doses per year were being produced. Today, this ability to take something in the lab and produce it for the masses quickly and cheaply helped in the momentous task of delivering COVID-19 vaccines globally. But it's not just about going big. In the future, chemical engineers will help to engineer medicines to be personal to each patient. Chemical engineers look at the full picture. Energy, food, water and climate change are all connected. In the early 20th century, chemical engineers were at the heart of the extraction, refining and distribution of fossil fuels, fueling prosperity and revolutionising transport for everyone. But now their focus is in the transition towards net zero by 2050. Renewable energy and hydrogen are two of the answers. The problem is the batteries and fuel cells needed to store and use the clean energy require finite metals and minerals. Chemical engineers are at the forefront of developing ways to store energy sustainably. At the turn of the 20th century, the bulk manufacture of ammonia to produce ammonium nitrate and urea revolutionised the amount of fertiliser that could be made. Half the world's population is fed due to this breakthrough. But food production is intensive and emits CO2. Chemical engineers are playing an increasing role in making agriculture and many industries more carbon neutral. And clean water is essential for life. The chemical treatment of wastewater has helped to eliminate or reduce many diseases. But water is set to become a scarce resource in many parts of the world. Take biofuels, a low-carbon alternative to fossil fuels, but it can take 10,000 times more water to make it. Chemical engineers need to reduce demand of water for agriculture and manufacturing. Tackling climate change is embedded in the thinking and design of new products and processes, from small modular nuclear reactors made on a production line to plastic that recycles multiple times and then eventually biodegrades. Chemical engineers are at the forefront of a circular economy, helping to solve the major global issues of today and tomorrow.
Chemical engineering was first established as a profession more than a century ago and has grown to span a diverse range of industries. As the Institution of Chemical Engineering celebrates its centenary, we look at the evolution of the sector and its place in society today.
Chemical engineers help to create the world we live in, from life-saving medical equipment to the screen you're watching this film on, and even the adhesive on the humble post-it note. The Institution of Chemical Engineers, IChemE, was established in 1922. In that time, the world of chemical engineering has changed, from just transforming raw materials into useful products to designing, constructing and managing complex processes that help to solve the global grand challenges. Chemical engineering has helped to save and improve millions of lives. In 1928, penicillin was discovered, but by 1940 there was still only enough for a few people. It took chemical engineers to scale up, and by 1945 over 640 billion doses per year were being produced. Today, this ability to take something in the lab and produce it for the masses quickly and cheaply helped in the momentous task of delivering COVID-19 vaccines globally. But it's not just about going big. In the future, chemical engineers will help to engineer medicines to be personal to each patient. Chemical engineers look at the full picture. Energy, food, water and climate change are all connected. In the early 20th century, chemical engineers were at the heart of the extraction, refining and distribution of fossil fuels, fueling prosperity and revolutionising transport for everyone. But now their focus is in the transition towards net zero by 2050. Renewable energy and hydrogen are two of the answers. The problem is the batteries and fuel cells needed to store and use the clean energy require finite metals and minerals. Chemical engineers are at the forefront of developing ways to store energy sustainably. At the turn of the 20th century, the bulk manufacture of ammonia to produce ammonium nitrate and urea revolutionised the amount of fertiliser that could be made. Half the world's population is fed due to this breakthrough. But food production is intensive and emits CO2. Chemical engineers are playing an increasing role in making agriculture and many industries more carbon neutral. And clean water is essential for life. The chemical treatment of wastewater has helped to eliminate or reduce many diseases. But water is set to become a scarce resource in many parts of the world. Take biofuels, a low-carbon alternative to fossil fuels, but it can take 10,000 times more water to make it. Chemical engineers need to reduce demand of water for agriculture and manufacturing. Tackling climate change is embedded in the thinking and design of new products and processes, from small modular nuclear reactors made on a production line to plastic that recycles multiple times and then eventually biodegrades. Chemical engineers are at the forefront of a circular economy, helping to solve the major global issues of today and tomorrow.
Chemical engineering was first established as a profession more than a century ago and has grown to span a diverse range of industries. As the Institution of Chemical Engineering celebrates its centenary, we look at the evolution of the sector and its place in society today.
Chemical engineers help to create the world we live in, from life-saving medical equipment to the screen you're watching this film on, and even the adhesive on the humble post-it note. The Institution of Chemical Engineers, IChemE, was established in 1922. In that time, the world of chemical engineering has changed, from just transforming raw materials into useful products to designing, constructing and managing complex processes that help to solve the global grand challenges. Chemical engineering has helped to save and improve millions of lives. In 1928, penicillin was discovered, but by 1940 there was still only enough for a few people. It took chemical engineers to scale up, and by 1945 over 640 billion doses per year were being produced. Today, this ability to take something in the lab and produce it for the masses quickly and cheaply helped in the momentous task of delivering COVID-19 vaccines globally. But it's not just about going big. In the future, chemical engineers will help to engineer medicines to be personal to each patient. Chemical engineers look at the full picture. Energy, food, water and climate change are all connected. In the early 20th century, chemical engineers were at the heart of the extraction, refining and distribution of fossil fuels, fueling prosperity and revolutionising transport for everyone. But now their focus is in the transition towards net zero by 2050. Renewable energy and hydrogen are two of the answers. The problem is the batteries and fuel cells needed to store and use the clean energy require finite metals and minerals. Chemical engineers are at the forefront of developing ways to store energy sustainably. At the turn of the 20th century, the bulk manufacture of ammonia to produce ammonium nitrate and urea revolutionised the amount of fertiliser that could be made. Half the world's population is fed due to this breakthrough. But food production is intensive and emits CO2. Chemical engineers are playing an increasing role in making agriculture and many industries more carbon neutral. And clean water is essential for life. The chemical treatment of wastewater has helped to eliminate or reduce many diseases. But water is set to become a scarce resource in many parts of the world. Take biofuels, a low-carbon alternative to fossil fuels, but it can take 10,000 times more water to make it. Chemical engineers need to reduce demand of water for agriculture and manufacturing. Tackling climate change is embedded in the thinking and design of new products and processes, from small modular nuclear reactors made on a production line to plastic that recycles multiple times and then eventually biodegrades. Chemical engineers are at the forefront of a circular economy, helping to solve the major global issues of today and tomorrow.
Chemical engineering was first established as a profession more than a century ago and has grown to span a diverse range of industries. As the Institution of Chemical Engineering celebrates its centenary, we look at the evolution of the sector and its place in society today.
Chemical engineering.
Ladies and gentlemen, please be ready as our events will kick off shortly. Before we begin, here are some kind reminders. Firstly, kindly record your attendance by clicking the link given in the chat box.
Secondly, please rename yourself with your full name for easier recognition. Thirdly, please make sure your microphone is muted throughout the whole event to avoid any interruption.
And lastly, if you have any question, kindly post it in the live chat box. On behalf of the organizing committee board, we will appreciate it if all of you can stay with us until the end of this event. Thank you.
A very good morning I bid to each and everyone. Welcome to IChemE Student Chapter Festival 2022. Thank you for joining us today. I'm Xiaomin.
And I'm Jin. We are honored to be your MCs for this memorable event.
Ladies and gentlemen, for your information, IChemE Student Chapter Festival is a national get-together event which involves IChemE student chapters from various public and private universities in Malaysia.
Yes, Chamin. Last year, IChemE-Universiti Malaya student chapter actually took the lead to organize our very first festival in collaboration with the University of Nottingham, Malaysia, IChemE student chapter. And to keep up with the astonishing achievement of the previous session, this year, we proudly present to you our second IChemE student chapter festival.
Yes, Jin. The main objective of organizing IChemE Student Chapter Festival is to foster a strong connection between IChemE student chapters in Malaysia, besides promoting IChemE among the students.
That's true. And apart from that, most importantly, IChemE Student Chapter Festival aims to expose the participants to the real world of chemical engineering.
Yes, and with that, we proudly announce and introduce the theme of IChemE Student Chapter Festival 2022, which is Engineering Drives Modernization, Manufacturing Sustains Mankind.
As all of us are concerned, this year, due to the uncertainties of the COVID-19 pandemic, our event is held online again.
Yes, Junjie, although we can't meet everyone face-to-face this year for this event, still, we can assure everyone that IChemE Student Chapter Festival 2022 will be very fun and interesting.
This very morning, we are delighted to have, firstly, Professor Engineer Dr. Abdul Aziz bin Abdul Rahman as the Deputy Vice-Chancellor of Development of University Malaya and the past chair of IChemE Malaysia Board. Secondly, Professor Engineer Dr. Law Chung Lim as the Dean of the Faculty of Science and Engineering of the University of Nottingham, Malaysia, and the chair of IChemE Malaysia Board. Thirdly, Ms. Tharshinye Soomaran as the Country Manager of IChemE Malaysia and an Associate Fellow of Malaysian Institute of Management.
Next, Ms. Kang Ying as the current President of IChemE-Universiti Malaya Student Chapter and the representative of IChemE Student Chapter Festival 2022. And lastly, participants from various universities and pre-universities. Ladies and gentlemen, now shall we all rise for the national anthem followed by the University Anthem of Universiti Malaya.
Thank you, ladies and gentlemen. Without further ado, I would like to invite the current president of IChemE-Universiti Malaya Student Chapter and the representative of IChemE Student Chapter Festival 2022, Ms. Gan Ying, to give her speech. Please welcome.
MC of the day, DJ. A very good morning, I bid to our honorable guest, Professor Engineer Dr. Aziz, Deputy Vice-Chancellor of University Malaya, as well as the past chair of IChemE Malaysia, Professor Engineer Dr. Chung, the Dean of Faculty of Science and Engineering of University Nottingham, Malaysia, as well as the chair of IChemE Malaysia, Ms. Tharshinye, Country Manager of IChemE Malaysia, and Professor Engineer Dr. Chung, Chair of IChemE PubSec, and all the participants. First of all, on behalf of IChemE-Universiti Malaysia Student Chapter and University Nottingham Malaysia IChemE Student Chapter, I would like to express my gratitude and warmest welcome to each and every one of you for being here with us today. We are pleased to have all of you with us for the IChemE Student Chapter Festival 2022, which is a national event aiming to connect all the student chapters in Malaysia, as well as to expose the undergraduates to the real world of chemical engineering via various talks and visits. To embrace the Industrial Revolution, we proudly present IChemE Student Chapter Festival 2022 with the theme of Engineering Drive Modernization, Manufacturing Sustain Mankind, wishing to highlight the manufacturing industries which are closely related to the engineering field. Therefore, I hope the participants will take this chance to have a closer look on the manufacturing industry, and I hope this event will be of benefits for all of you. Taking this opportunity, I would also like to give credit to the organizing committees for all the hard work and effort. Due to the uncertainty in the midst of this COVID-19 pandemic, we have to carry out this event virtually, and it's not easy for the organizing committees. Nevertheless, the organizing committees bend over backwards to ensure the participants have a wonderful experience. So kudos to the organizing committees. Well, I don't want to take too much of the time. I hope all the participants have fun. Once again, on behalf of IChemE-Universiti Malaysia Student Chapter and University of Nottingham Malaysia IChemE Student Chapter, I sincerely thank and acknowledge every one of you here and those who extended help to us for making this event a grand success. Thank you so much for having me here, and I'll pass the floor back to MC.
Thank you, Ms. Gan Ying, for the speech. Next, I would like to call upon Ms. Tharshinye Soomaran as the Country Manager of IChemE Malaysia and an Associate Fellow of Malaysian Institute of Management to deliver her speech. Please give a minute for our speaker.
Okay, can you hear me now?
Yes.
Okay, all right. Thank you for the introduction, MCs. And I apologize for not putting up the backdrop, which I will improve as we move forward. So without further ado, let's begin. Salam Sejahtera and Salam Satu Malaysia. Before I begin with my welcome remarks, I would like to acknowledge two other speakers joining us this morning. Professor Chung, Dean of Faculty of Science and Engineering, University of Nottingham, Malaysia. Also, the Chair of IChemE Malaysian National Board for term 2021 and 2022. We also have Professor Dr. Aziz Abdul Rahman, Deputy Vice-Chancellor of University Malaya, past Chair of Board of IChemE Malaysia. Ladies and gentlemen, honored guests, colleagues, and members of IChemE, I am delighted to welcome you to the second IChemE Student Chapter Festival 2022. Despite the challenges we continue to face in this pandemic, this is the second time we host IChemE Student Chapter Festival on a virtual platform. This morning is indeed special because it's a Saturday, promoting IChemE among students as well as exposing the participants to the real world of chemical engineering. Here, in this virtual platform, we also see immense support from the chemical engineering fraternity. We have more than 160 participants joined us today on a Saturday morning. So that's indeed wonderful. So once again, ladies and gentlemen, thank you. Thank you for joining this event. It seems Malaysia entered the 5th decade since the chemical engineering program first started in the country. The oldest university in the country, Universiti Malaya, started its undergraduate program of chemical engineering back in 1974. Then, in the following decade, UTM and the National University of Malaya also started their chemical engineering programs at years 83 and 84 respectively. IChemE had its presence in Malaysia for 16 years now and started the Malaysia branch in 2006 and plays a vital role in promoting general advancement of the knowledge of chemical engineering, not just locally, but internationally. Student chapters are unique to IChemE in Malaysia. They have been a real success story for us. With that, I am delighted to be part of the second IChemE Student Chapter Festival 2022, organized by IChemE-UM Student Chapter in collaboration with IChemE-Universiti of Nottingham, Malaysia Student Chapter. The festival aims to foster a strong connection with IChemE Student Chapter across Malaysia and the region, promoting IChemE among students as well as among academics who gather to share their insights and innovations relevant to chemical engineers across the wide range of sectors we work in. The theme for 2022 is Engineering Drives Modernization, Manufacturing Sustains Mankind. Our focus is to encourage and explore the emerging opportunities and challenges for the chemical engineering profession and process industries throughout our region around this theme. Our invited speakers have been specially selected to challenge our thinking and bring alternative perspectives to this discussion. Building on previous events and conferences, the Student Chapter Festival is the opportunity for the chemical engineering students and associated disciplines to come together as a friendly collab to network and learn from each other and share knowledge. It provides a platform for cross-pollination across a wide range of industries, facilitating innovation. A blend of industry and academia will come together to discuss and share knowledge and explore the latest advances and best practices to face the challenges of the 21st century in our region. I am hopeful the participants will take this opportunity to forge networks and partnerships. This event continues to be a wonderful opportunity for IChemE student chapters to understand each other's work and explore opportunities. Have a great event, and kudos deserved to the organizing committee for continuing the good work despite the uncertainties. And well done. Over to you, MC.
Thank you, Ms. Tharshinye, for your inspirational words. Now, I would like to invite Professor Engineer Dr. Chung Lim, as the Dean of the Faculty of Science and Engineering of the University of Nottingham, Malaysia, and the Chair of IChemE Malaysia Board, to give his speech.
Thank you, MC Chun Jie and Chiao Ming. Good morning, ladies and gentlemen. I am delighted to see the organizing and the launching of IChemE Student Chapter Festival 2022, which is a nationwide get-together event which allows various student chapters and IChemE student members across the country together in this platform, learn something new and exchange knowledge. This event is indeed an excellent platform that brings together students from all student chapters, IChemE student chapters, and meet the experts from industry, And further, this event provides opportunities to students to learn insights and best engineering practices from the industry experts. It is hoped that students who participate in this carnival would expand their horizon and have a better idea about chemical engineering, about the industry, about the latest advancement and development. According to OECD, Economic Cooperation and Development, Future of Education and Skills 2030, 3 sets of skills are highly demanded in the future job market. They are: number 1, cognitive and metacognitive skills, which include critical thinking, creative thinking, learning to learn, and self-regulation. Creativity and critical thinking are needed to find solutions to complex problems. Metacognition, lifelong learning, and understanding other cultures are needed to adapt to changing environment. Number 2, social and emotional skills, which include empathy, self-efficacy, responsibility, and collaboration. Workers whose jobs require social and emotional skills are unlikely to be replaced by technology or artificial intelligence. Achievement at school and higher learning institutions depends on a number of social and emotional skills, such as perseverance, self-control, responsibility, curiosity, and emotional stability. Some social and emotional skills are a prerequisite for successful participation and performance in academic settings. Number 3, practical and physical skills, which include using new information and communication technology devices. Physical and practical skills are essential for students' overall functioning and well-being. In the new era, students' digital skills need to evolve with technological development. I was told that a series of events and talks have been prepared and scheduled, namely, role of chemical engineer in food processing. Food security is an important aspect, and chemical engineers are able to play an important role in ensuring sufficient supply to the entire population. We have recently learned that the war between Russia and Ukraine has impacted the food supply and hence jacked up the food price in European countries. For your information, IChemE has rolled out a green paper which is related to water, energy, food nexus. And we as chemical engineers definitely can play a significant role in ensuring the human race continues to receive sufficient water, energy, and food. Role of chemical engineer in palm oil industry and related to sustainability. For your information, ladies and gentlemen, UN, the United Nations, SDG, Sustainable Development Goals, are gaining popularity now. Many companies are looking into this aspect, and hence there are a lot of demand of such expertise, which is in sustainability and sustainable development in a company operation setting. Engineers life in Top Glove. Top Glove is world #1 glove producer. It is good to learn the engineer life in such a big corporation. And there are other activities such as bonding session, lucky draw, group quiz competition for participants. I hope you take full advantage of this program and gain as much knowledge in industry practices as possible, and also expand your network and know more fellow IChemE student members. I would like to thank all speakers, participating companies, which include Top Glove, Sarawak Energy, and KLK Oleo. Without the participation and support, this event would not be materialized. Your participation and your support to IChemE Student Chapter Carnival 2022 are highly appreciated. And ladies and gentlemen, can I borrow your thumbs and also your palms? Give them a round of applause, a virtual clap. At the same time, my sincere appreciations to the organizing committee, UM IChemE Student Chapter, who is the host, and UNM IChemE Student Chapter, who is the co-host. You have done a very good job, yeah, from conceiving the idea, formulating the plan, planning the event and the program, communicating with industry experts and companies, publicizing the event, and finally making it happen. This shows that you are indeed very committed to the event. Again, I would like to borrow your thumbs and palms, yeah, give them a round of applause. Thank you, all committee members. I hope you have an engaging, fruitful, and productive IChemE Student Chapter Carnival 2022. Thank you very much. Thank you.
Thank you, Professor Engineer Dr. Law, for your speech. Moving on, let us invite the Deputy Vice-Chancellor of Development of University Malaya and the past Chairman of IChemE Malaysia Board, Professor Engineer Dr. Abdul Aziz bin Abdul Rahman, to deliver his speech.
Good morning, everyone. Thank you, MCs. Good morning, everyone. My good friend, Prof. Lau, current IChemE chairperson, Tharshinye, country manager, students, Miss Gunn, from student chapter. I'm very happy to be here. Whenever that I get called from IChemE, I can't resist from attending. I'll try my very best to attend. And I'm also happy to see that finally this student chapters is moving. This is a great get together. Now, when I look at the theme of the festival this year, engineering drive modernization, manufacturing sustain mankind. So I would like to just give some thoughts on this. Now, engineering not only driving modernization, in fact, it is the core of human civilization. When we talk about civilization, we moved a bit throughout the history. So from wearing something, we wear something else, up to our situation now. Now, I feel that the civilization is still taking place in a different dimension. We explore the universe more. So modernizing and civilizing humankind, I think we have a big role that we are playing, and we will play in the future, I believe. So this is a theme that goes very well with our role now. Now, there is also sometimes a thinking process that this IR4, Industrial Revolution 4, is very much focused on manufacturing, where there is only mechanical engineers are involved. That is not true. I think all engineering disciplines are equally involved in this IR4, including chemical engineering. I was told that about 80% of our participants here today are chemical engineers and mechanical engineers and all that. So we are all in it together. With that thinking process, let's move on. Let's keep yourself with whatever that you require for the future. Now, when we started our, when I say we, myself, Prof. Lau, okay, of course I am a bit more older than Prof. Lau. When we started chemical engineering, the fundamentals are the same from now and 20, 30 years ago. But what's different is now is opportunities, opportunities to learn, opportunities to be there. I remember in our department where I studied in chemical engineering, we only had one computer then. And now I think everyone probably have more than one device. So these are all enablers. So now we have plenty of enablers everywhere, every corner there are enablers. So use these enablers, upgrade yourself, be counter, and contribute to modernization, civilization, and let's achieve all this in the most sustainable way. Now, human being, we are very good at rising to the occasion. When we have challenges, we somehow will overcome the challenges. Now, the fact that we are talking all in the comfort of our home and offices says a lot. In the past, I remember whenever that we organized an AGM and all that, it has to be physical. Our day would have started yesterday with looking for parking and this and that. Now that is being taught. Therefore, there are still a lot of things to contribute, and this kind of activities that we are doing today, talking, discussing, networking, exchanging ideas, is definitely in the right direction. I wouldn't want to take a lot of time of yours, but I'm very happy with this kind of happening. Do more, engage more, discuss more, contribute more, and modernize Malaysia and the rest of the world more. Bring us into the right civilization And with that, thank you very much.
Thank you, Professor Sorry.
Yeah.
Thank you, Professor Engineer Dr. Abdul Aziz, for the speech. Now, without further ado, we would like to invite Professor Engineer Dr. Abdul Aziz to officiate our event. Please welcome.
Okay, ready everyone? I hereby officiate IChemE Student Chapter Festival. Enjoy the program.
Thank you, Professor Engineer Dr. Abdul Aziz, and thank you for the video. And with this, we proudly announce that IChemE Student Chapter Festival 2022 has officially begun now.
Ladies and gentlemen, it is our photography session now. All participants are encouraged to turn on your cameras for this session.
Everyone, please be ready. Taking the picture of the first page. One, two, three. 1, 2, 3. Picture of the second page. One, two, three. 1, 2, 3. Picture of the third page. 1, 2, 3. 1, 2, 3. All right. Thank you.
Thank you very much.
Thank you for your cooperation. Ladies and gentlemen, with this, the opening ceremony of IChemE Student Chapter Festival 2022 has come to an end. We, on behalf of the organizing committee board, would like to extend our best wishes to all participants. The next session will be an industrial talk by Engineer Dr. Ching from IChemE Malaysia Food and Drink Special Interest Group.
Without further ado, we proudly present to you a talk entitled Role of Chemical Engineers in Field of Food Processing by Engineer Dr. Ching from IChemE Malaysia Food and Drink Special Interest Group.
Before moving on, allow me to highlight a few gentle reminders. Firstly, please make sure your microphone remains muted throughout the whole session to avoid any interruption. Secondly, if you have any question that you would like to ask the speaker, kindly scan the QR code presented on the screen to proceed to Slido to pose your question. Or you may click the link provided in the chat box. And lastly, we will have a photography session at the end of this talk together with our speaker. And hence, everyone is highly encouraged to turn on your cameras during our photography session later.
Now, without wasting any time, allow me to introduce our honorable speaker of this session to the floor, Engineer Dr. Ching. For your information, Engineer Dr. He is currently the chair of IChemE Malaysia Food and Drink Special Interest Group. Also, he is an associate professor of the Department of Chemical and Environmental Engineering at the University of Nottingham, Malaysia, and a committee member of the Institution of Engineers Malaysia Agriculture and Food Engineering Technical Division.
Yes, Xinjie, not only Engineer Dr. He is a chartered member of IChemE, he is also a chartered engineer of the Engineering Council UK, a professional engineer under the Board of Engines Malaysia, and Fellow of Higher Education Academic UK. Engineer Dr. He graduated in Chemical Engineering from the Institute of Science and Technology before he completed his Master of Science in Food Processing and Engineering at Universiti Putra, Malaysia. Later on, he obtained his PhD in Chemical Engineering at the University of Nottingham, Malaysia.
Without further ado, let us invite Engineer Dr. He to give his talk. Please welcome.
Thanks to the MC for the nice introduction. And just to double check, are you able to hear my voice?
Yes, we can hear you.
Yes.
Okay, thank you. And next, just to double check again, are you able to see my screen?
Yes, Dr. He.
Okay, thank you. All right. So again, thanks for the introduction and the invitation to present this talk in this prestigious event. And the title of my talk today is Roles of Chemical Engineers in the Field of Food Processing. Just to add on a little bit to my biodata, I have started my food journey since the first day I worked after my graduation. Okay, so upon my graduation, actually I worked in the cocoa industry, and my job basically evolved around the cocoa processing and even the chocolate making. So after that, after 10 years, I actually quit my job and I continue my PhD. And until now, I still involved in food aspect of teaching and also research and development. So, so today I will talk about this topic, why we chemical engineers are important to the food industry. And of course, like Prof. Abdul Aziz have mentioned, we are not working alone. And of course, we work with engineers from many industries, okay, from many backgrounds. So chemical engineers is one of the contributing expertise in many industries, including food industry. So overview of food industry in Malaysia, agriculture sector contributes to about 8.2% to national GDP. Okay, so this is quite a high percentage. Okay, as you know, Malaysia, traditionally we started from agriculture. Okay, when the country gained independence in 1957, we started from agriculture, then slowly moving towards manufacturing, and eventually to what we have today. Okay, growth of agro-food subsector is about 5.4% per annum, and food processing sector account for about 10% of the Malaysia's manufacturing output currently. Okay, so these are just some of the basic statistics of the food industry in Malaysia. And currently, we also have quite established processed food industry, which contributed to about 21.76 billion to the nation's economy. And but of course, at the same time, we do still need to import some food, okay, because we are not able to produce sufficient for our own, so we do still need to import some processed food, and which amount to 20.27 billion. This statistic is from 2019. Okay, so in Malaysia, we actually have quite many food industry sectors. Okay, so the biggest one is the livestock and dairy industry, where poultry processing constitute about 60% of the meat industry. Okay, poultry processing is like chicken meat, chicken farming, this part of the industry. Okay, fisheries, total export of seafood processed product exceed 1.1 billion. Okay, next is cereal product, flour-based product. So we actually have cereal manufacturing Okay, flour-based manufacturing is just like biscuit, cookies, all these products. We are net exporter, okay, of cereal preparation product and constituted about 3.1 billion in 2019. Yeah, just to let you know, the statistic is until 2019 because it takes us a few years for the Department of Statistics to finalize the data. So probably this year only they will release the statistic for 2020. So that is why you see the statistic is a bit backdated. But we can still use this as some of our guide to the scenario of the current food industry in Malaysia. Okay, chocolate and sugar confectionaries. I used to work in this sector in the cocoa and chocolate industry. So we actually export cocoa preparation, were valued at 5.5 billion in 2019. Actually, Malaysia is one of the biggest cocoa product. Okay, I try to group it under cocoa product because cocoa product include not only chocolate and also some other semi-finished product. Okay, like cocoa butter, cocoa powder, all these are semi-finished product. So Malaysia actually is one of the largest in this region. Okay, so we actually have investor that actually set up their plant. Okay, from foreign countries, set up the plant in Selangor, Johor, Penang. Okay, to manufacture this product. Okay, pepper and pepper products. As you know, Sarawak is an important state that is have pepper planting and also export pepper, which amounted to 246.6 million in 2019. Okay, fruits and vegetable, we still do need to import. Okay, but at the same time, we also export, especially to our neighbor Singapore, recorded at 1.1 billion. Okay, palm oil-based product. We are the world largest exporter. So I believe that everyone knows Malaysia is a key player in the palm oil industry, and the world's second largest producer of palm oil. Export earning reached 63.7 billion. Okay, in 2019. So due to the COVID pandemic, the government has actually channeled 3.15 billion to the agriculture sector through the stimulus package and budget 2021. So from here, we can see that we have actually quite a big varieties of food industry in Malaysia. So this food industry actually need engineer, okay, engineer from various discipline, including chemical engineers. Okay, so let us see how we actually define chemical engineering and also the food processing principles. Okay, chemical engineering principle usually is defined as to write down mass and energy balance for individual equipment or for entire plants with a view to size equipment for a given unit operation or to determine and control the performance of the equipment and the plant. So perhaps some of you have done or is still in the process of doing your design project. So you know, to design a plant, you need to have the layout of the plant, and then after that you calculate the mass and energy balance for individual equipment like heat exchanger, reactor, or distillation column. And then after that, you might want to design it for different capacity. Okay, so all these you need to apply chemical engineering fundamentals to actually carry out this calculation. So what about for food processing principles? Okay, so food processing is defined as practices used by the food and beverage industry. Okay, when we talk about food industry, usually is both our food and beverage industry to transform raw plant and animal materials, okay, such as grain, produce, meat, and dairy, and so on, into safe and nutritious consumable products. Although the description is not as technical as chemical engineering, okay, but we still do need to use the fundamentals from chemical engineering, like heat and like mass and energy balance, to actually design or operate the food processing equipment. Okay, because food processing equipment is also more or less the operational wise they are more or less the same as what we learn from typical chemical engineering textbook. But the difference is in food processing, we are dealing more with food product as compared to in chemical engineering, you are dealing with perhaps more towards chemicals. Okay, so let us look at differences in terms of unit operation. So in chemical engineering, mostly you will touch on this design of this equipment. Okay, the typical textbook equipment like reactor, distillation, filtration, evaporation, heat exchanger, sedimentation, milling, grinding, and so on. So these are some of the typical equipment that you will see in, let's say, in a chemical process plant. Okay, especially reactor, you will see it almost in every plant. Okay, heat exchanger, also almost in every plant, including pump, compressor, all these equipment. Okay, so typically it's around 20 plus unit operation. Okay, and then, but for food processing, you have a lot of varieties of equipment. Okay, like cooking, frying, baking, salting, brining, drying, dehydration, freezing, refrigeration, fermenting, pickling. Okay, packaging, canning, bottling, pasteurization, extrusion, and etc. Okay, so these actually constitute almost double of what we normally see in typical chemical process plant. Okay, because there are just too many varieties of food product or beverage product that we can produce from a single raw material. Okay, even like milk product, of course you can produce into milk, the drinking milk. Okay, but you also can produce into milk powder, then the cheese, okay, then butter and so on. So different type of product, you might need different equipment. Okay, like milk powder, you need spray drying, okay, to make the cream. Okay, then you need a centrifuge. Okay, so so you can see that from a single product, you will need to use different equipment to produce different product from a single raw material. Okay, so for examples, typically in the food industry, what are some of the equipment that actually is linked to our chemical engineering fundamentals or education? Okay, let's say in coffee roasting, this is a coffee roaster. I used to run a cocoa roaster before, so the principles are almost the same. Heat transfer is very important because you need to develop the temperature profile, and you actually need to follow the temperature profile during the heating process to develop the flavor. And in order to develop the flavor, the mass transfer is very important because as you heat up the coffee bean or cocoa bean, it will actually evaporate some moisture, and this moisture actually carried away some of the flavor volatiles. Okay, but at the same time, you don't want it to disappear too much. Okay, otherwise it will affect your coffee flavor. Okay, so the mass transfer part is important. So all these things also involve you need to have a very good process control strategies. Okay, fats and oil processing. This is especially in the palm oil industry. So the rheological part of the product is very crucial. Okay, we don't want to, we have to make sure we extract out the correct part of the oil. As you know, the palm oil seed, different part of the seed will give you different types of fat or oil. Okay, the palm kernel or outer part of the seed. Okay, compared to the inner part, this will give you different quality, different oil type and different rheological properties. And of course, fluid mechanic is important. Okay, because you need to transport the liquid from one source to another source. Okay, spray drying is equipment where mainly is used to produce a powder or granular product. Okay, one of our Malaysia's most favorite drink, Milo, is actually produced from spray drying. That is why you get the very fine granule structure or powder. Okay, so spray drying, as the name implies, is a drying process. So you actually need to look at the heat and mass transfer aspect, the heating, and also the moisture evaporation. And in the design of this spray dryer, CFD is also quite important. Okay, CFD is computational fluid dynamics. It's a simulation where you simulate the momentum, heat, and mass transfer in the equipment design. Okay, so momentum, heat, and mass transfer, I believe you have learned something like Navier-Stokes equation and so on. So these are the fundamentals that is actually used in this equipment. Okay, of course, particle mechanics is important. Okay, because you're producing powders. Okay, powders is you have to follow the particle characterization category to when you design or you collect the product from the spray dryer. Okay, of course, in the food industry, there are many other equipment that we actually can link what we learn in the classroom to the actual application. Okay, like chocolate refiner, this in the chocolate industry, where you actually produce this equipment actually convert the chocolate paste into powder, and then after that the powder will be melted to make into the finished chocolate. Okay, but of course it's still in liquid state before it pass through the cooling process. Okay, and then you have the retort chamber. This is for the can product. Okay, product inside the can. Okay, so you need to use this equipment to actually reduce the microbiological count and to sterilize the product. So actually, you also apply both chemical and microbiological or biochemical aspect in this equipment. Okay, evaporator, as the name implies, is actually just to remove the moisture from the product, and this is mainly used in production of concentrated fruit juice. So some of these concentrated fruit juice that you buy from Speedmart or supermarket is actually made from this equipment. Okay, it actually removes most of the moisture and give you the very concentrated fruit juice. So when you bring back home, you just need to add water to reconstitute back into the fruit juice. Okay, so all this equipment, including the one in the, excuse me, let me cover a bit. The sun is coming through the window. Okay, all this equipment actually require a lot of chemical engineering fundamentals, okay, including like in plant design, safety, process integration, waste management. Okay, waste management part is also quite important because there are a lot of waste generated from the food industry. But of course, this can be made into other value-added product. Okay, biochemical, process economics, and so on. Okay, in terms of career in food industry, there are various career prospects in this area. For example, the typical one is of course in the production as a process engineer. Okay, so if you intend to work in the factory, so most likely you will be designated as the production engineer or process engineer. But of course, you can also choose not to work in the factory. Okay, then you you can go for sales or training. Okay, because some company actually do provide training to staff or to factory personnel in equipment or hygiene, sanitation, safety, etc. So all these chemical engineers also can contribute. Okay, project consultancy to, let's say, to design and set up a plant, product development. Like myself, last time I used to work in product development where we actually formulate new chocolate recipe, okay, from the sugar-based to sugar-free recipe, and also testing out different type of ingredient. Okay, QA, QC, research and development, like what I'm doing now in the university. Okay, like I said, there are a lot of waste generated from the food industry. Okay, so we also need chemical engineers to look into this aspect. Okay, the waste treatment, meaning that including wastewater. Okay, not only the waste from the food industry. Okay, some of these waste, for example, the palm kernel waste. Now, one aspect is to actually use this as the biomass to actually generate energy, okay, for the boiler. Okay, so this is something that that can help to reduce the waste from a food manufacturing operation. Okay, hygiene and safety. This is very important because we don't want to produce product that is not safe for us to consume. Okay, something as simple as cleaning a food processing equipment is actually a very big, how to say, you really need you really need to have good knowledge in this area to clean a food processing equipment. Okay, unlike we wash our cooking pot at home, you just turn on the pipe and then take a sponge and wash. But food processing equipment, you cannot wash like that. Okay, not all food processing equipment can be dismantled easily and washed. Okay, let's say you are dealing with like heat exchange. Just take a simple one, heat exchanger equipment to actually cool down the milk product, the liquid milk. Okay, so how to wash the heat exchanger? This is also an area that need actually engineers to work on. Okay, because to dismantle equipment is not so straightforward, and then you need to use a special technique. Okay, of course, this also related to GMP, good manufacturing practice, and also it involves some certification. Okay, so like in food industry, we have this HACCP certification, quite similar to HACCP, but not exactly equivalent to HACCP, but the idea is the same. We want to make sure everything is safe. Okay, not only at the product, not only at the process side, okay, but also at the product side. Okay, because HACCP will make sure the product produced is safe for us to consume. And of course, there are many more. Okay, of course, there are many more, but the typical one is, of course, the first one in production and process, as a production and process engineer. Okay, so this is a salary survey by IChemE, and you can see that food and drink actually is in the top 10 of the, or I put it this way, some chemical engineers actually work in food and drink industry, and it was ranked within the top 10 according to the salary survey. Okay, so in these statistics, so 7% of the respondents they interview actually work in this sector, food and drink industry. Okay, so more or less we have covered the equipment, the career side, and also some of the prospect of chemical engineer in this conventional area, conventional part of the industry. But as an engineer, okay, not only chemical engineer, as an engineer, we have to prepare ourselves for the future. Okay, so in the future, I believe you know, human population are growing, and we don't have sufficient food. to feed everyone. Okay, like Prof. Law already, Prof. Law mentioned about the war crisis in Ukraine. Okay, so this actually affect the global food supply chain and affect the import or exportation of food product to many countries. So we need to look for other food source. Okay, in future, probably this is one of the future food that we need to eat. Okay, it actually already exists in many food culture. Okay, just that it's not the main type of ingredient we use in our dishes. Okay, so one aspect is they call future protein, which is eating the bugs or insects. Okay, there's also this lab-grown meat, where they actually take the cell from the let's say the cow and grow in the lab and eventually collect the tissue and make into meat. Okay, there's also this lab-grown shrimp. Okay, this industry actually has been started in Singapore. Okay, I believe if I'm not mistaken, by this or next year they're going to operate and actually start big commercial selling of this artificial meat product. Okay, they are still meat, but just that they are lab grown. Okay, jellyfish is one of the area that food scientists or even chemical engineers or food engineers can look into it, because this it has a very low calorie, but it's very nutritious to our body. Okay, this is a mayonnaise made from plant. Okay, it's not made from it's not made from egg. Okay, so you actually use an alternative source of protein from the plant. Okay, to make mayonnaise. So as a chemical engineer, we have to get ready to know more about this food product. And also in future, this industry, you will see this industry start to come out, maybe not so soon in Malaysia, but it will come out one day. So if you are ready, then you can actually join this particular food industry and use your knowledge or chemical engineering knowledge in this sector. Okay, so I'm coming to the concluding remarks. So positive economic growth are still forecasted for the food industry in Malaysia. Chemical engineers provide support to other engineers in food processing operation. And chemical engineering fundamentals are keys to a better understanding of many food unit operation. Okay, and also we as chemical engineers should be always ready for future food. Okay, I have arrived to the final slide of my presentation. Thank you very much. And also please select food and drink SIG in your membership subscription, okay, in the IChemE website. Okay, thank you. Over to you, MC.
Thank you, Engineer Dr. He, for the informative talk. Engineer Dr. He, you may unshare your screen now. So now let's proceed with a short Q&A session. For your reminder, if you have any questions that you would like to ask the speaker, kindly scan the QR code presented on the screen to proceed to Slido to post your questions, or you may click the link given in the chat box. We will direct your questions to our speaker. Dear Engineer Dr. He, please be patient while we are collecting the questions from the participants.
Let's see the first question. What are the aspects you enjoy the most in this field? What's your answer to this? Okay.
Yeah, I just take example when I was in the cocoa industry. I also mentioned that I look into chocolate formulation and making chocolate. So the most enjoying part, of course, was eating the chocolate. So almost every day I have to eat chocolate. So during that time, because the only way to know whether it tastes good or not good, I mean, it's just to taste it. So almost every day I have to at least take half a bite of the chocolate. So over the 10 years, I think I have already eaten more than enough chocolate that I need to eat for, for my whole life. So nowadays, I don't really eat so much chocolate anymore because of that. Okay, thank you.
So let's proceed with the second question. So, do job opportunities in food processing engineering big in our country?
Yeah, actually, we have a lot of food industry. I mean, we have a lot of food industry, but when I say food industry, it actually include both the upstream and downstream. Okay, like I just take example like palm oil. At the upstream, at the farm level, farm processing, actually you also need engineers. Okay, like chemical engineer to actually get the oil, okay, from the farm. Because that's the first step in the oil production for let's say palm oil. Then after that, you have the oil refinery downstream, where actually the oil is processed into many products. So if you look into this aspect, Malaysia actually we have both the upstream and downstream. Okay, unlike scenario in overseas. Okay, let's say in Europe. Mainly they have downstream. They don't really have upstream. So in Malaysia, we have both upstream and downstream. So the demand for engineers, okay, including chemical engineer, food engineers, and also other engineers is actually quite big in Malaysia. Okay, but of course I don't have the actual statistic now. But if you just randomly flip through the newspaper or even look at job street, you will see there are posting of these job opportunities for engineers in the food industry. Thank you.
Thank you for the answer.
Moving on to the next question. Talking about waste management, are all waste generated in the food industry treatable? If not, how would the industry usually deal with the untreated waste?
Okay, for those really that you cannot be treated, of course, I take one example. Last time, my PhD student are dealing with this waste product. Although the waste product is from the milk industry, but because according to the law, you cannot actually treat it according to the law, even though you want to treat it, but you are not allowed to treat it. So for these untreatable, cannot be treated waste, you just have to send it to the third party to actually carry out the disposal process. Okay, maybe they will use an incinerator to dispose. Okay, so that is one way to actually dispose this type of product. Okay, so to answer this question, untreatable waste product. So you have no choice, but you just have to send to the third party company to dispose for you. I cannot remember the name of the company, but it's actually at Sendayan. In fact, it's not far, not until that far from the place I'm staying now, Seremban. I think in Sendayan or in Enstek, that side, somewhere around there. Okay, they have the facilities that can treat this untreatable waste. Okay, thank you.
Thank you very much for your answer.
Due to time constraints, let's end this Q&A session with the last question. So, is the money big in this industry?
Putin actually asking this question. I can see from the screen. Okay, is the money big in this industry? But of course, it depends what is your benchmark, right? Of course, you cannot benchmark against oil and gas industry because these are totally different. Okay, just to put it into a more easier perspective, let's say the palm oil industry, and now, if I'm not mistaken, a few days ago, because of the war crisis in Ukraine, there is a shortage in this oil, not shortage, a disruption in the logistic and supply chain, including for the edible oil. Okay, so actually, palm oil now is in high demand. Now it's in high demand, so the price actually shoot up. So is the money big? Then of course it's big because Malaysia is the biggest producer of this palm oil product. So of course, like I say, it depends. You benchmark again which industry, but in the context of Malaysia economy, the money is big. Okay, I hope this answer Putin's question. Thank you.
Thank you once again, Engineer Dr. He. Dear participants, for those unanswered questions, don't worry. They will be answered later by Engineer Dr. He, and the answers will be posted on our social media. So do follow IChemE-UM Student Chapter and UNM IChemE Student Chapter on Instagram and Facebook by clicking the links provided in the chat box to get the latest updates.
Before we move on, Engineer Dr. He, do you have anything to add on?
I just wish to add on, do consider food industry as one of your, do consider career in the food industry. Okay, like myself, I'm from chemical engineering background, but eventually I work in the food industry. So open up your, how to say, your scope. Okay, don't limit to, I know a lot of students or chemical engineers, they prefer the oil and gas industry, but there are many other industries outside there. So do widen up your choices. Thank you.
All right, once again, thank you, Engineer Dr. He. It is truly our honor to have you with us today. Now, before we end this session, I would like to ask everyone to switch on your cameras for a photography session together with our speaker.
Okay, everyone, please be ready. I'll take picture for the first page first. 1, 2, 3. For the second page, 1, 2, 3. And for the third page, 1, 2, 3. Okay, thank you, everyone.
Thank you for your cooperation, and this marks the end of our second session. Now, let's take a short break before we continue with our next session, which is an industrial talk by Dr. Jaybalan Tamahrajah from Kuala Lumpur Kepong Berhad, KLK Oleomas. Dear participants, before going for a break, please be reminded to mark your attendance by scanning the QR code on the screen or by clicking the link provided in the chat box. Please sit back and grab a cup of coffee. We shall meet each other again at 10:15 a.m. later.
Welcome back everyone, and we are now in our third session of our event today, which is an industrial talk entitled Role of Chemical Engineers in Palm Oil Industry Sustainability. For this talk, we are proud to have Dr. Jaybalan Tamahrajah from Kuala Lumpur Sdn Bhd, KLK Oleomas, to share his experience in the palm oil industry over the past few years. Before moving on, here are a few gentle reminders. Firstly, please make sure your microphone remains muted throughout the whole session to avoid any interruptions. Secondly, if you have any question that you would like to ask the speaker, please scan the QR code on the screen, or you may click on the link in the chat box to post your questions. And lastly, we will have a photography session at the end of this talk together with our speaker. And hence, everyone is highly encouraged to turn on your cams during our photography session later. Now, without wasting any time, allow me to introduce our honorable speaker of this session to the floor, Dr. Jaybalan Tamahrajah. For your information, Dr. Jaybalan is a senior technologist at Kuala Lumpur Sdn Bhd, KLK Oleomas, and he is currently an associate member of IChemE Malaysia and the Palm Oil Processing Special Interest Group, called SIG. Not only that, he is also a member of the Malaysian Oil Scientists and Technologist Association. Dr. Jaybalan received his Bachelor of Science and Master of Science in Process Engineering and Energy Technology from the Birmingham University of Applied Sciences, before he obtained his PhD in Industrial Chemistry from the University of Edinburgh. Over the past few years, he has been conducting studies, investigations, improvement and development of oleochemical products produced via sustainable processes. Now, without further ado, I would like to pass the floor to Dr. Jaybalan. Please welcome.
Thank you, everyone. Thank you for inviting me on presenting at this IChemE special student chapter. And allow me to just start the presentation. So, as already mentioned, I am Dr. Jaybalan Tamahrajah from KLK Oleomas. I'll be just presenting what I have experienced so far in the palm oil industry and in the oleochemical industry. So, first I would like to mention some things, some information on palm oil and the palm oil processing industry. The integration and application of the knowledge that we have learned as chemical engineers in our courses, respective courses, and also as engineers in general, and how we apply them in the palm oil industry. Also, there are always challenges lying ahead in the palm oil industry. So I would like to just point out some of them so that the future engineers, such as you all here present today, can take on these challenges. So the palm oil processing industry, I would like to first give some information that you may already know, that palm oil is one of the most efficient oil crops in the world. It is actually the most efficient palm oil oil crop in the world. It produces, on the left-hand side, you can see 400% more oil per used land than any other vegetable oil crop. And on the right-hand side, the graph, you can see that the green columns, the palm oil is produced at a rate where 40% of the global vegetable production is accounted to palm oil. Palm oil grows along the equator region, plus minus 10 degrees of the equator region. And therefore, Indonesia and Malaysia are predominantly responsible to produce most of the world's palm oil. We are blessed with this location. So we are also happy that the engineers in Malaysia and the future engineers in Malaysia can capitalize on this golden crop. So in Malaysia, Malaysia is the second largest producer and exporter of palm oil worldwide. It is responsible for 10% of all the oils and fats production. We currently we use around nearly 6 million hectares of land. It's only 17.5% of our land mass. So we produce 40% of the oil, vegetable oil in the world, but we use very little land. So it's a very efficient oil crop in that sense. And as far as Malaysia is concerned, it is one of the top 10 largest export earner in terms of product in for Malaysia. It employs 600,000 people directly and 2 million people indirectly. So if you can imagine, if there's a household of 3 or 4, you can safely say that nearly 8 to 10 million people are surviving and happily living from the capitalization of palm oil. And 2017 saw the centennial celebration of commercial palm oil planting. So the first palm oil plantation was in Batang Berjutai, Tharshinye Estate, in 1917. So it has been already, as of today, probably 105 years. So it's a very mature industry. There are still many opportunities in the industry. Chemical engineers need to be creative on how to solve issues that the palm oil are currently facing. These are challenges that we need to take on head on, so that we are able to always capitalize on the golden crop and its profitability. So the starting point of a journey where we have the palm oil plantation, so each hectare has about 150 trees. So from these 150 trees per hectare, you get 25 metric tons of FFBs, fresh fruit bunches. These fresh fruit bunches go to the palm oil mill, as you can see here. So when they go to the palm oil mill, they go through a series of processes. So first, the fresh fruit bunches are sterilized. These are done to make the cell walls and the fruit soft. And they are threshed so that they are separated from the empty fruit bunch. They are further digested and pressed to gain the raw oil with some solid particles. They further go into clarification, where the solid particles are removed to a significant extent. They are centrifuged further to remove further minor particles in the micro region, and then you get your crude palm oil. Here in the middle, in between digestion and pressing, you go through, you actually get the kernels. Of course, in the fruit itself, you have the mesocarp and you have the kernel, where this kernel is separated, further cracked, winnowed to separate the shell and the wax or the oil within the palm kernel. And then they go through wet separation and the palm kernel is achieved. Now, you have the oil. When you have the oil, you go through a series of processes again in order to refine the oil. Of course, when you get the oil from a palm oil mill, is just CPO, is crude palm oil. So you have to further refine it in order to meet certain quality and standards. So there are two ways. One is physical refining, and another way is chemical refining. The difference between the two is basically just how you remove the free fatty acids, either through a physical way, where you just inject steam and remove the free fatty acids in the oil. And the other way is you use a chemical method in which you convert the free fatty acid to soap via addition of sodium hydroxide, in which we call caustic soda commonly. After that, it is bleached to improve the color and deodorized in a steam column under low pressure to remove any impurities, aldehydes and ketones that may cause these odor issues. Furthermore, then you get your refined, bleached and deodorized palm oil. So now you have your refined, bleached and deodorized palm oil. They contain palm stearin and palm olein, which is the solid phase and the liquid phase of RBDPO. So you have to also separate these for their necessary purposes, where the olein is used for cooking oil and the stearin is used for mostly solid applications such as butter, margarine, and the sort. So these are normally done through a series of thermomechanical processes, where the palm oil is first controlled with temperature, and the temperature is gradually reduced. And while the temperature is gradually reduced, then a certain fraction of the palm oil is separated in order to get the necessary palm oil fraction, which is probably olein or stearin. And the olein is further fractionated to super olein and soft PMF and hard PNF and other oils which are of importance in the food industry. So the palm oil processing value chain is a good one, where the FFB is going through the palm oil mill and the palm oil refinery, as we have seen previously. It also goes to the crushing plant that we also have seen briefly in one slide. It also produces some waste, where it is known as palm oil mill effluents. The palm oil mill effluents and the EFBs are previously considered as waste material, but now people are trying to find more and more applications of POME and EFBs to gain a higher value chain across the palm oil industry, the palm oil processing units, and also to have a more sustainable process where the waste is reduced and the amount of products and the amount of recycling is increased. So the POME is basically rich in methane, where it can be enriched and sent into a gas turbine, combusted, or it can be burned in a burner, sent to a boiler to generate steam and supply the palm oil mill with steam, where it is used in the digester and in the sterilization unit. The kernel crushing plant is of course being used to gain the CPKO, which is the crude palm kernel oil. where all goes into the palm oil refinery. Yeah, and depending on the customer's needs, they are further fractionated for specialty fats producers, biodiesel producers, and oleo producers. Yeah. So the biodiesel producers and the oleo producers are basically non-food applications, where the specialty fats are for food application. So in an oleochemical plant from palm oil, basically what we do is we get the palm oil, the RBDPO. Yeah, actually sometimes we get the PO, we refine it in the plant itself. Yeah, and then we go through a series of processes, which is first would be hydrolysis and hydrogenation. The hydrolysis part splits the palm oil to fatty acids and glycerin. And these fatty acids can further be processed by introduction of methanol into methyl esters. Yeah, and these methyl esters, through a series of processes which involves a heterogeneous catalyst, can be converted further into fatty alcohols. And these methyl esters and fatty alcohols can be further derived into specialties like surfactants and lubricants of special design. Yeah, these are very niche products that the palm oil industry can profit from, just from the CPO and the CPKO. And we have a large range of products that we can use, such as cooking oils, frying oils, potato chips, body wash. These are surfactants basically. Lipsticks for cosmetics, glycerin is used for cosmetics, vitamin E, propionials, and a myriad of products that we can produce from palm oil. So it is really not unrealistic to say that more than half of the products that you see in the supermarket are made from palm oil. Yeah, probably maybe 60 to 70% are made from palm oil. You definitely have some remnants of palm oil in any products that you see in the supermarket. Yeah. So the integration and application of technical knowledge that you have gained from your courses in the universities will definitely be used in the palm oil industry. Of course, you have the basics of physics, chemistry, maths, and biology. That's your fundamentals. Then you further refine it into an engineering point of view. Yes, and then you are trained in such a manner that you see the process and the equipments to improve it further and to become more sustainable on one side and safer on the other side. So we are really trying in the process that the process is actually safer, yeah, in terms of the mechanics, in terms of the process, in terms of the electrical and instrumentation, yeah, in order to further improve the quality of life. So the technical knowledge that you might use in the palm oil industry, in process technologies, are the basics of distillation, crystallization, filtration, and separation. You would need mathematical modeling for catalyzed reactions, spray crystallizations. There was once upon a time that we simply used Excel to model these units, but now you have more sophisticated softwares such as Aspen and ChemCAD and the sort. Safety and loss prevention, where you perform management of change, where you have a process and you want to change the process to become better. You would need to consider the safety point of view, where the improved process must be safer than previous process. And in terms of big projects, you can use hazard analysis to evaluate the safety measures and the safety scenarios in a certain process unit, and provide recommendations to the management in which you can make the process safer. The thermodynamics, where you can use it to, for example, increase the splitting degree in a hydrolyzer. System analysis, the control of processes. These are important for E&I engineers, electrical and instrumentation engineers, to perform, but they need to understand the process as well. So the cooperation between engineers is vital. The underlying chemistry, where we need chemists, yeah, and chemical engineer to find out. Normally, as engineers, we treat process unit as black boxes, something coming in, something going out, and we do our calculations based on that. But if you are well versed in chemistry, you can actually see the side reactions which are happening within the process, yeah, and probably use this information to reduce these side reactions via catalysis and directed reaction units. Economic evaluation, of course, if you are doing some improvement, you would need to spend money. When you spend money, people would always ask, how can I get this money back? So you would need to do an evaluation on the cost analysis on how the returns are after we provide a better plant and process for them, for the management and for the company. Sustainability and environment is now the topic, the hot topic currently, with net zero and circular economy coming into place. So we would need to optimize resources further and convert waste into wealth. Chemical engineers and engineers in general would need, they have a wide career option, yeah, such as plant operation. In history, we can see that in the palm oil industry, that mechanical engineers were very, very prominent in producing machines that would improve the oil extraction rate in the palm oil mill. So the participation of a mechanical engineer is vital to also be instrumented in improving the productivity of the palm oil mill. Not only process engineers, we need mechanical engineers, we need process engineers, we need chemical engineers, we need E&I engineers, in order, all working in tandem to produce the oil of the best quality from a palm oil mill. And you would also need chemists, where they monitor the quality, and sales engineers and sales personnel to actually sell our product. So if you don't have anything to, don't have any sales, then we don't have actually any reason to produce such good quality, right? So with the current situation, I think all engineers are vital for the palm oil processing industry, yeah. So in the palm oil processing value chain, I would like to actually focus into how we can actually convert waste to wealth. Some can say that we are producing EFBs. Yeah, these EFBs can actually be converted into useful material that we can use within the palm oil mill and also being sold to customers. Yeah. So what are the challenges lying ahead? So I like to focus on the waste valorization. Yeah, the waste valorization in the palm oil industry is vast because we have I think nearly 3 times more biomass produced than actually CPO produced. So if we can convert all this biomass into products such as oleochemical products like carboxymethylcellulose, biodiesel, and conversion of palm oil to edible products, this would be incredibly profitable for the palm oil industry. So these are the challenges that future engineers have to take on. So I have here a simple schematic Sankey diagram on how we can do that. So here we have the plantation, and we get the FFBs from the plantation. The FFBs are converted into oil in a palm oil mill. Yeah, these are probably 25%. I'm being optimistic. And these are then further converted into RBDPO and RBDPKO at the rate of 20 and 5% respectively. So most of these oils are used for food. Nearly 75% are used for food. Now, and the rest, about 6% is used for oleo. And in oleo itself, 6.2% is used for basic oleo and 0.05% is oleo derivatives. Now, only 25% we are using as products. Now, these EFBs, some probably will be sent back to the plantation for mulching purposes. Yeah, this would create a more circular economy. Yeah, while the rest may be used to produce electricity via a burner, and then these burnt gases are sent into a boiler unit and to create steam, and this steam is used to propel a turbine, a steam turbine, where it produces electricity. The waste steam coming out of the turbine can be used in the palm oil mill and in the refinery or in the palm oil oleochemical complex, yeah, as a network. So we need to try to use and valorize this waste into useful products as well, such as, for example, when you produce surfactants, you will produce waste water containing surfactants. Now, if you produce wastewater containing surfactants, these surfactants are useful. When these surfactants are useful, they can actually use surfactants in the palm oil mill to gain more oil from the wastewater that is coming out from the palm oil mill, because the palm oil mill has some wastewater which contains oil. So the function of the surfactant is to actually absorb the oil and release only the water coming out from the palm oil mill. Yeah, and when you have already absorbed the oil, then you can extract it out and produce more oil extractions. So in that sense, you are creating a more circular economy and increasing the productivity of the palm oil mill. Yeah. So now we are also talking about Industry 4.0. What does it mean for students such as you all? We have to understand that the IR 4.0, Industry Revolution 4.0, is a very, very powerful tool in which the plant thinks for itself. Yeah, when it thinks for itself, that means the plant knows when a pump goes down, it knows what to do in order to repair it on its own and then run the plant again within a matter of seconds and minutes. Because in order to, if you do not rectify the matter in terms of minutes, then you shut down the whole plant. And if you shut down the whole plant, you do not produce anything. If you do not produce anything, you do not have sales. So in that sense, it's a very powerful tool. But however, you would need a vast amount of experience on what happens under different case studies, such as what happens if the process pressure goes down, goes up, fluctuates too much, and the same for temperature and concentration. Yeah. So you create all these case studies and put it into a server, and the system learns for itself to say that when one of the case studies happen, what should the system do? And it will further learn automatically on its own. Yeah. So this is important for chemical engineers. It's also very important for software engineers, yeah, for the future, the current software engineering students for the future. Now, what do you need other than that? You need to manage relationships. These are very important. You need to have good relationships with your peers, with your management, and with your subsequent workers. You need to have a leadership in a professional role, and you need to communicate ideas formally. Yeah, these are all important so that people actually understand what you're trying to do. Yeah, and actually trying to help the company to attain a more profitable and productive process. So, what does palm oil processing industry expect from chemical engineers nowadays, or engineers in general? Yeah, they expect you to apply the knowledge and understanding in practical situations. Yeah, you need to manage relationships. Yeah, so that things are done in a more formal and communicable methods. You need to commit high standards of professional and ethical conduct. Yeah. So when you register yourselves with the Board of Engineers Malaysia, so you will have a code of ethics that you need to follow, and you have to follow them to the letter. Yeah. And these have to be also in tandem with the profitability of a company that you're working with. Yeah. So you have to continue professional development. Yeah. Gain more knowledge. Yeah. These the things that you learn in the university are good and important as a basis for your development in the industry, but you continue to learn in the industry, and you have to actually accept this. And when you accept this, you gain more professional development and more knowledge and also competence. So how can you develop? You have to connect. You need a vast amount of networks, yeah, with mechanical engineers, chemical engineers, sales, logistics, and the sort. You go back to basics. Once a system becomes too complicated, you go back down to the basics and slowly build back up, yeah, to make it more understandable. Yeah, these are things that you will learn in the industry. You have to uphold professionalism. You know, you have to maintain your code of conduct. Huh? So with that, I thank you for your kind attention, and I'm ready to accept any questions that you may have. Thank you.
Thank you, Dr. Jaybalan, for the insightful talk. Now, let us proceed with a short Q&A session. For your reminder, if you have any question that you would like to ask the speaker, kindly please scan the QR code on the screen, or you may click on the link in the chat box to post your questions. I will direct your question to our speaker. Dr. Jaybalan, please be patient while we are collecting the question from the participants.
Yes, okay.
Okay, so now let's see the first questions. May I know how palm oil industry responds to the 3-monochloropropan diol, which is believed as a harmful compound to human health?
Okay, so now these 3 MCPDEs, yeah, the chloro compounds that we have, the organic chloro compounds that we have, and the inorganic chloro compounds that we have, we are really looking into it really seriously. And there are basically the two main ideas that we have in the industry in general. So some claim that this chlorine, which is existing within the FFBs and the oil, is coming from the water that is irrigated in the plantation. Yeah, of course they do not use treated water. They use water which is of acceptable quality, which contains a significant or some residual amount of chlorine, and these then will be integrated within the network and the components of the palm oil tree itself, and from there you get these 3 MCPDEs. So the idea they had was to actually prevent the existence of chlorine at the plantation site itself, so that it significantly reduces in further processes. That is one way to do it. Another way is actually they use basically in the palm oil mill or in the refinery, they use a lot of water to actually flush out those 3 MCPDEs which are existing. So these basically means that you have to use more water. Yeah. So if you have to use more water, you increase your cost. So if you increase your cost, that wouldn't be profitable for the system, and it's also not good for the environment, because it's considered as increased water usage and water treatment that you need to do in order to discharge the wastewater into the environment at acceptable levels. So these are the 2 ways that they actually probably do. So one is actually patented by our Mr. Unitan in his company, where he has an extraction column. The 3 MCPDs are extracted with in a column where the drops of water surface area is increased significantly, and the MCPDE is actually extracted directly in contact with the water. Yeah. So, but this again, it means that you have more wastewater to deal with. Yeah. Okay. I hope that answers the question. Thank you.
Thank you for the answer. And now let's move on to the next question. Do palm oil can be an alternative for petroleum, palm biodiesel? If so, why it's not widespread in our country, since petroleum isn't renewable source?
Okay. So palm biodiesel is actually a very good alternative to conventional diesel or petroleum-based diesel. We are currently using it probably maybe B5, B10, at very low rates. Yeah. So number one is you have to look at the market. Okay. So now currently CPO price is actually nearly 7,000 ringgit. Yeah. But the petroleum price is actually near maybe half of that. I'm not currently following the petroleum price, the crude oil price, but it is lower than of palm oil. So if you were to process palm oil into biodiesel, the cost of biodiesel is actually higher than conventional diesel. Yeah. So the market would not want to use oil which is more expensive. Okay, that is one way of seeing it. The other way of seeing it is, if you want to see it in a technical point of view, you have something that is called the cetane number. Yeah. This is basically the idea of previously in petroleum, where you use gasoline or you use diesel, you add lead. So now you have lead fuel and unleaded fuel. Yeah. So the lead was used to actually control the combustion within the engine, so it doesn't combust in a greater impact and spoils the piston inside the engine. Yeah. So you add lead. So then they remove lead. There was unleaded oil because they control the so-called cetane number to a certain level. I believe it's probably 60 to 80. So if you're within that range, then it's okay. Now, petroleum-based has a very low cetane number. So they control the combustion within the engine at a very controlled rate, because the petroleum industry has developed within the years to control the cetane number. But pumped up biodiesel has just started. Yeah, so they are finding ways to control the cetane number and be competitive with petroleum-based fuels. Yeah, so that's the technical point of view. Also, you have then these combustibility. Yeah, so of course it's comparable. The biodiesel and the conventional diesel is comparable. We are working towards to become better in petroleum diesel. Yeah. So I hope that answers the question as well.
Okay, thank you for the answer. So now let's move on to the third question. Will company with different field of study, such as oil and gas company, accept other field graduates such as food, biotech, that is also from chemical engineering?
Yes, of course, definitely. It doesn't mean that you are all chemical engineers, you are all engineers, okay? You all have the same fundamentals. So it doesn't mean that once you go into food, you cannot come into oil and gas, because you always build from that fundamental. You have to have a strong fundamental basic idea of engineering so that you can build upon whatever the industry that you are in. So now, if you are going from food, let's say, or biotech into oil and gas, yes, you have to still go from the basics, but you will eventually learn how the oil and gas industry works, yeah, and how their processes are. They are no different. They are just based on the same fundamentals. Don't worry about that. Okay.
Okay, thank you for the answer.
Yeah.
And the next question is, where is Malaysia today in the route to B20 or B30 biodiesel? Are we far behind Indonesia?
We are catching up with Indonesia. The idea of using more biodiesel in our fuels is actually a very good one. You know, you actually close the cycle. You know, you are more sustainable. The CO2 that is combusted within a biodiesel powered car is actually being used back as CO2 for the crops, the plantation. These are all good things, but the maturity of the petroleum industry is currently higher than that of the palm oil industry. So we have to catch up. Yeah. When we catch up, yes, we can be at B20, B30, or B100. Yeah. I want to give you a simple example. Okay. Diesel, the word diesel, the fuel diesel, is based on the name of the person who invented it. His name is Rudolf Diesel. Yeah, he's a German chemist and inventor. Yeah, he actually produced the first engine for cars. Yeah, based on peanut oil. Okay, this is based on peanut oil. So he was on his way to London to produce an engine which is actually based on peanut oil. But on his voyage, on the way to London, from Germany to London, he didn't make it. He didn't make it. So if we were to imagine hypothetically that he would have made it to London, today all cars would be from vegetable oil, you know. But unfortunately, it isn't now. It's all based on petroleum. Yeah. But so he died in 1870s, 1900s. Yeah. So we are still way back. Yeah, 100, 120 years back from what the petroleum industry is today. Yeah. So we have to make sure that we catch up with the petroleum industry. Okay. Thanks.
Okay, thank you for the answer. And the next question is, Marcop has been set up by the government. how does it help your processing to be more sustainable? How does this help your company or palm oil industry as a whole?
Well, because I'm not within this system of Corp. I don't know whether they are actually helping my company. Probably they are, but I cannot comment much on this because we want to maintain a good relationship with the government. So I believe they are actually doing a lot in terms of helping the palm oil industry. Yeah, thanks.
Okay, thank you for the answer. And the next question is, how does MSPO certification scheme change the operation of processing to be more sustainable?
Okay, this is basically RSPO is already there to have more sustainable palm oil being produced. So they have ISPO, the Indonesian Sustainable Palm Oil, and now currently we have the MSPO. These are all basically ideas of different institutions helping palm oil to become more sustainable, to make sure that we follow certain guidelines, yeah, like such as we don't plant oil palm trees on peatland, yeah, on land which is having a high amount of carbon stocks, because when you irrigate, when you start to till with vehicles, then you release those carbon stocks to the atmosphere. So they try to produce that. They also try to trace the oil from which palm oil mill it's coming from. Yeah, it's also vital that in this certification that you produce the palm oil at the lowest CO2 emission as possible. So they do that in that terms. They do control, help give us a guideline to control those emissions. Yeah, these are also very important, and yeah, they help us certify, yeah, that these are actually sustainable oils that the EU can, or any other Western countries can actually confidently use without having the concern of increased CO2 emissions, and forced labor and the sort. This certification help us to follow these guidelines. Yes. Yeah, I hope it answers the question. Thank you.
Okay, thank you for the answer. And the next question is, do you think that improving palm oil extraction productivity will have a side effect of affecting palm oil quality and properties?
Yes, it will. But then, therefore, we are here as engineers to maintain that quality and properties. Yeah, this is our job. Okay. Yes, of course it will affect, but we are the ones who have to control it. Yeah.
Okay. So the next question is, how do you view the EU's blanket ban on palm oil-based biofuels? Is it also a major setback to sustainable oil palm plantations?
Okay. I give you my view on this. Okay. So the EU is having the impression that palm oil is only used for food. Okay. So if you use it only for food, if you are having the impression that it's only supposed to use for food, when you use it for something else, the EU thinks that you are actually cutting some food sources for some people, which is not the case, because some fractions of palm oil cannot be used as food. Yeah, you would need too much of fractionation in order to do that. So we have to make the EU officials understand that it's actually not as such. You cannot use you can use, of course, all the palm oil for food, but you have to see the practicality of it. It's not just simply you use palm oil for food only. Yeah. There are some fractions that we are not able to use, and we need to find out sources to make our processes and our product palette more sustainable. Okay. Good.
Okay, thank you for the answer. And the next question is, does your company use satellite imaging and drone technology in plantation? How common or economic is it in the palm oil industry?
Yeah, we actually use drone technology and satellite imaging. How common? Probably not that common, but we are starting to use it because we need to, most importantly, we need to monitor the heat images of these plantation areas to avoid any wildfires which are happening, probably because of the high amount of global warming currently happening within our region. So this is very important, and I think it will become more and more prominent in the industry. How common or economic is it? I think the economic part is yes, it is an important one. But if you do not do this, then it means that you probably, if you're not monitoring them, then if actually some forest fires happen, then the critics may say that palm oil is actually not sustainable. You know, you are not being sustainable. Your company is not being sustainable, and that affects your sales. So in any way, you have to start doing it already. Yeah. Thank you.
Okay, thank you for the answer. And the next question is, why is deforestation for oil palm plantation harmful when oil palm trees are natural carbon sinks just as other green plants?
This question, why is deforestation for palm oil harmful? I think if I understand the question correctly, the person is asking, why is deforestation harmful when actually oil palm is a natural carbon sink? Because deforestation is, I assume that deforestation of tropical forest is meant here, right? Let's assume that it's a tropical forest that we are currently having, and you actually deforesting in order to have oil palm plantations. So it is claimed generally that tropical forest is a better carbon sink than oil palm. Yeah. So when you cut down those trees and you grow oil palm, then the magnitude at which you are actually absorbing carbon dioxide is lesser. It doesn't mean that it's totally not sustainable, but it's lesser. So if it's lesser, critics might say that deforestation is not good. Yeah. So you have to maintain a certain level of carbon sink within your palm oil plantation to actually render it sustainable. Okay.
Okay, thank you for the answer. And the next question is, are computer image processing and data analytics the roles of chemical engineering graduates? What is the basic knowledge or qualification required?
Okay. Computer image processing and data analytics. Okay, if you can do it in a more sophisticated way, such as software, you need to know more on software engineering and information technology. Yeah. As chemical engineers, but I am trained myself. I am trained as a chemical engineer in and out. So what I do is simply very simple. You know, I capture pictures. And I analyze the data from that pictures. I believe you have something in your chemical engineering courses like bubble columns. You know, if you have bubble columns, you have bubbles rising up to the top of the column, and mass transfer is happening within the column. And how do you know how much mass is transferred? You actually make a picture out of the bubbles. You know the size of the bubble, then you will calculate the beta, the heat, the mass transfer coefficient, and from the mass transfer coefficient, you can actually say, okay, I've extracted so much of 3 MCPD or GE or something like that. So the same concept you use in the plantation site. You just take a picture and then you do your analysis from there. Yeah, I do it in a very simple way, but there are ways that you can do it in much efficiently. Yeah, so I think you would need the software engineering and information technology you need to gain more knowledge on that. Yeah, thanks.
Okay, thank you for the answer. And due to time constraints, let's end this Q&A session with the last question. Is 0.3 MCPDE and 0 GE achievable in today's technology?
This is a question of thermodynamics. Okay, every system is definitely possible. Yeah, the only thing is that your rate of removal is asymptotic. Yeah, if you imagine a graph, on the y-axis is rate of removal and the x-axis is time, is asymptotic. Yeah, it never reaches 100%. If you want 100%, the time is infinity. This is the thermodynamics of it. Yeah, so if you ask me, yes, it's possible, but time is infinity. Okay.
Okay, thank you for the answer once again, Dr. Jaybalan. And dear participants, for those unanswered questions, don't worry. They will be answered later by Dr. Jaybalan, and the answers will be posted on our social media sooner and later. So do follow IChemE-UM Student Chapter and UNM IChemE Student Chapter on Instagram and Facebook by clicking on the links provided in the chat box to get the latest updates. And before we move on, Dr. Jaybalan, do you have anything to add on?
Just continue to work hard and the industry will reward you. Thanks.
All right. Once again, thank you, Dr. Jaybalan. It is truly our honor to have you with us today. Now, before we end this session, I would like to ask everyone to switch on your cams for a photography session together with our speaker.
Everyone, please get ready. First page, 3, 2, 1. Once again, 3, 2, 1. Second page, 3, 2, 1. Once again, 3, 2, 1. Page, 3, 2, 1. Once again, 3, 2, 1. Thank you.
Thank you for your cooperation. And with this, our third session has come to an end. Dear participants, please be reminded to mark your attendance by clicking the link provided in the chat box. Before we move on to the next session, which is the bonding session, please allow me to make some introduction regarding the virtual exhibition, which will be held on the second day. So, ladies and gentlemen, do you feel time constrained to attend industrial talks and frustrated when you could not rewatch the industrial talks recording? This is a whole new platform showcasing the working life and insights into the chemical engineering industry by various engineering professionals who have been dedicating their lives to improve the chemical engineering industries. Through this session, you will be exposed to the actual job scopes and responsibilities as a chemical engineer in diverse manufacturing industries. Also, the expected range of salary and some personal and exclusive pieces of advice by these professionals. Do not miss out this session, especially if you are still in the midst of deciding your future career path. Here are the invited engineering professionals who are also the alumni of University Malaya and University of Nottingham, Malaysia, who have provided valuable insights into the engineering industries. Ms. Ng Chi Shen, she is an engineer who has been stepping into the engineering field for 5 years across the water treatment industry and pharmaceutical industry. Mr. Toh Beng Leong, who had his bachelor's degree in University Malaya. Mr. Toh Beng Leong is currently holding the position of Continuous Improvement Lead at Carrick Company, while Ms. Nur Bashira, who is a final year student in the Department of Chemical Engineering of University Malaya, had joined IChemE Palm Oil Processing Special Interest Group, or SIG, as a University Roadshow Coordinator. Mr. Samuel Yeo, who is a graduate from University Malaya, is currently holding the alkylation process engineer position at ExxonMobil. Mr. Lam Ho Eun as a process engineer at Dispet Balestra, and Mr. Yong Eun Kiet as resin upgrading manufacturing process engineering group lead at ExxonMobil. Up next, we have Ms. Chu Sho-yin, who is a graduate from the University of Nottingham, Malaysia, is currently a senior process engineer in the R&D department at BRB Malaysia Sdn Bhd Shah Alam. Mr. Wong Chung Jie, who is also a graduate from the University of Nottingham, Malaysia, is currently working as a first-line manager in Nestle. While Mr. Bong Jen Hao, as a graduate in the University of Nottingham, Malaysia as well, is working as a project engineer in Gas Ancillary Services Private Limited Company. Are you excited to know more about the information shared by them? Do not miss out on our virtual exhibition on the website by scanning this QR code. If you miss the QR code, don't worry, as we will publish this QR code on our social media as well. Kindly note that the virtual exhibition can only be viewed in optimum mode with your laptop or PC devices for now, and the phone version will be updated very soon. So remember to follow IChemE-UM Student Chapter and UNM IChemE Student Chapter on Instagram and Facebook to get the latest updates. Here are also gentle tips for you all here. There are some questions on the Kahoot challenge on the second day of our event, with a total prize pool of 425 ringgit Malaysia. And the questions are very much related with the information shared by these industrial professionals. So be sure to check out their sharings to stand a bigger chance to win the rewards. Dear participants, please also be reminded that the second day of our event falls on the 2nd of April, which is on next Saturday, and we will start at 9:30 a.m. On the second day, we will be having an industrial talk entitled Life as an Engineer in Top Glove, a virtual site tour to Kuala Lumpur Kepong Berhad, KLK Oleomas, and as well as an IChemE virtual carnival. Looking forward to seeing you all next Saturday. Now, dear participants, our next session will be a bonding session, so stay tuned for it. And we shall see each other again in the bonding session later at 11:30 a.m. Thank you and bye everyone.
Hi everyone, I'm Jihn and I welcome each and every one of you back. We are now in the most exciting session, which is the bonding session of our event. Aren't you excited for that? Now, the facilitators will assign each participant to respective breakout rooms accordingly to play exciting games. Dear participants, kindly rename yourselves as your group number _ your name for our bonding session. Meanwhile, please wait patiently while you are being assigned to respective breakout rooms. Thank you and have fun. Dear participants, please be reminded that the bonding session is limited up to 100 participants only. If you are not registered for the bonding session, you may join us on the second day of our event day, which is on the 2nd of April, which is on the next Saturday at 9:30 a.m. Thank you. Dear participants, kindly note that the bonding session is only limited to the first 100 participants who have registered for the session previously, and the lucky draw session will be limited to bonding session participants as well. However, don't worry, as we will have activities for you to win away cash prizes and vouchers on day 2 as well. So to join us on day 2 and see you.
Welcome back, participants. We're now at the last highlight of our event today, which is our lucky draw session. I'm Devin.
And I'm Xiaomin. We'll be a moderator for this lucky draw session.
Well, it is very exciting, right, Xiaomin?
Yes, Devin. It is time for some fun. Let's see who are the lucky ones today. For your information, each winner will receive a cash prize of 30 ringgit as an award. Doesn't it sound interesting?
Yes, Xiaomin. Now, how I wish I could participate in this lucky draw session too. However, I'm fortunate enough to moderate this session with my partner, Xiaomin, to bring happiness to each of you here. Okay, now, without further ado, let us cut to the chase and enter our lucky draw session now. And let's see who is the first lucky person. A mind count, 3, 2, and 1. Congratulations, Nur Iza Inshira binti Hashim. Now, Nur Iza, would you mind muting yourself and answer some questions from me?
Yes.
Yes. Hi, Nur Iza. Would you like to do a brief introduction of yourself first?
Hi. I'm sorry. Pardon me? Can you repeat?
Oh, yeah, sure. Would you mind do us a brief introduction of yourself first?
Sorry, I don't get what are you saying.
Can you hear me?
No.
Sorry, can you hear me?
Yes.
All right. So first of all, would you like to do some brief introduction of yourself to us?
Yes.
Hi, Nuiza, can you hear me? Hi, Nuiza. Are you there?
Yes.
Can you hear me?
Yes, I can.
Yeah. So, all right. I believe you're undergoing some internet connection problems. So yeah, perhaps you can use the chat box feature. Would you like to do a brief introduction of yourself? Perhaps where are you from? Your hobbies?
Okay.
Yeah.
Okay. Hello, my name is Nur Iza Inshira binti Hashim. You can call me Iza. So I am from UiTM Shah Alam, currently in semester 2, studying chemical engineering, and I live in Serembai.
All right. So nice to meet you. Are you excited of our event today? Like, how did you enjoy yourself throughout the whole event?
Yeah, I do. During the game, it's so fun.
Great to hear that. And I'm so glad to hear that you actually enjoyed yourself, especially in the bonding session. Now, actually, you did win a cash prize of 30 ringgit Malaysia. So it's quite a grand prize for you. So may I know how you're going to use this money?
Maybe I will spend it during my stay in the campus, buying some food.
All right. Thank you for your answer. And congratulations once again, Isa.
Thank you.
All right, let's see who will be the next lucky one. On my count, 3, 2, 1. Congrats to Govind Raj. Are you there? Do you mind unmuting yourself to do a brief introduction about self, where are you from, and currently what are you pursuing?
Yeah, can. Hello everyone, my name is Govind Raj. I'm from University Malaysia Pahang. I'm staying in Sungai Petani Kedah, and I'm doing my third year in chemical engineering. Thank you.
Oh, so how do you find the event so far? Do you enjoy yourself,
Yes,
especially
really.
after winning the money?
Actually, before that also, I already enjoyed the event, the morning session with my team, Group 10. It's a very, I get a lot of new persons. I introduce a very new person. I have a very interesting games there. So I really enjoyed the session.
Okay, looks like you're having fun there. Thank you for your answer.
Welcome.
Right, moving on. Let's see who will be our third lucky participant. So let's find out in 3, 2, and 1. Congratulations, Adil Fikri bin Ahmad Faizal. Adil Fikri, would you mind unmuting yourself to do a brief introduction of yourself?
Hello, hi. My name is Adil Fikri bin Ahmad Faizal, and so I'm a first year chemical engineering student in Universiti Malaya, and I am from KL. So yeah, that is, I guess, my introduction.
All right, thank you. Now, since you are still in your first year of chemical engineering, may I know a little bit of the reasons, perhaps? Why did you choose chemical engineering as your undergraduate program to pursue?
First of all, I think maybe most of us say that we're taking chemical engineering because they love chemistry, which is one of my reasons, because I loved chemistry when I was in Form 4. And after that, during foundation, I enjoy my chemistry and everything. So, and then, yeah, I pursued for chemical engineering.
Yeah, so all in all, did you enjoy yourself throughout the whole event? Like, did you learn something from our event today?
Oh, it was splendid. Yeah, it's extravagant, I guess. Extraordinary. I learned a lot of things, all the industry, and from where I saw myself that maybe there's a future for me in this course and chemical industry. So yeah,
Yeah, great to hear that. And I believe the valuable knowledge shared by our speakers just now does really help you in your future studies and as well as your future path as a chemical engineering student. So thank you very much. And once again, congratulations.
Looks like we only have 3 places left. So let's move on to see who is the 4th winner. 3, 2, 1. Congrats to Sol Shikai. Do you mind unmuting yourself, Shikai?
Yeah, hi, thank you. Thank you very much. So I'm Shikai. I'm currently a second year chemical engineering student studying in University Malaya. And yeah, that's about it. What else do you want to know?
What will you do with the amount of money that you just won?
30 ringgit.
That's quite a lot though, 30 ringgit for one person.
Buy like
one person.
buy like two cups of booze or not. 2 cups of booze or not.
Okay. Okay, thank you very much for answering my question.
Thank you.
Wow, it is very exciting, right? And I believe it's very thrilling. So, and I believe everyone here is curious about who is our next blessed one. So let the wheel of the fate tell us in 3, 2, and 1. Congratulations, Muhammad Nur Fazli bin Roslan. Would you mind unmuting yourself to answer some of my questions? Hi, Muhammad Nur Fazli, are you there?
Yes.
All right. Congratulations on winning the 30 ringgit Malaysia as your cash prize. So may I know how are you going to use this money?
I think I will use this money to buy my daily basis, such as I want to go to cafe to eat for my lunch, dinner, and so on.
So did you enjoy yourself throughout the whole event today?
Yeah, I
Was it
enjoyed.
fun? Was it interesting?
Yes, of course, it's very interesting. And actually, I do love about the especially when the breakout room where we play games, the bonding session, it's very nice.
All right, great to hear that. Now, if we are going to organize the third IChemE-UM Chapter Festival next year, would you like to come and join again?
I think if I have a free time, I would like to join again.
All right, great to hear that. And I look forward to seeing you next year.
Okay.
Congratulations once again.
Thank you.
Now, we only left the final winner. Let's see who will be the last blessed one. 3, 2, 1. Congrats to Hao Wei-Jian. Do you mind unmuting yourself and do a brief introduction?
Hi everyone. Can you guys hear me?
Yeah. We can hear you clearly.
Oh, sorry. Hi everyone. My name is Wei-Jian. You can call me Danny in short. And I'm from IChemE-Universiti, Malaysia, and currently in my third year, semester 1 of my chemical engineering degree. Nice to meet you all, and thank you for the prize.
Okay, so how do you find the event so far? Which part is the most interesting part of the event?
I would
in your
say
opinion?
I would say both the session is quite interesting. I joined the talk session just now, and also the bonding session like just now. Both sessions are fruitful for me, and especially the bonding session where I can interact with students from nationwide. So yeah, it's actually a quite good experience for me. Yeah, that's all for me. Thank you.
Okay, thank you very much and congrats again.
Thank you.
Congratulations once again to all winners and thank you very much for your participation. For your information, our technician team will approach you later for the giving of prizes.
Yes, charming. And with that, we shall call it a day for the first day of our event now.
Yes, Devin. Finally, we have come to an end for the first day of our event, and hereby, on behalf of the organizing committee of IChemE Student Chapter Festival 2022, we would like to once again thank you for staying with us until the end of today's session.
Now, before we end, I'd like to ask everyone to turn on your cams for a photography session to commemorate today's sessions.
Okay, everyone, please be ready. Page 1 first. 3, 2, 1. One more. 3, 2, 1. Okay, page 2, please be ready. 3, 2, 1. One more. 3, 2, 1. Okay, page 3. Please be ready. 3, 2, 1. One more. 3, 2, 1. Okay, thank you.
Thank you for your cooperation.
Now, dear participants, please be reminded that the second day of our event falls on the 2nd of April, which is on the next Saturday, and we will start at 9:30 a.m. sharp. So on the second day, we will be having an industrial talk entitled Life as an Engineer in Top Growth, a virtual site tour to Kuala Lumpur Kepung Berhad KLK Oleomas, and as well as a virtual IChemE carnival. So, how exciting, right? It's much appreciated if everyone can attend the second day of our event on time, and we do look forward to seeing your faces again next Saturday. Now, before you leave, we would like to ask all participants to scan the QR code presented on the screen or by clicking the link provided in the chat box to fill in the feedback form for our future improvement. Thank you for your participation today once again.
See you on next Saturday and goodbye.